Okay, in this video, we're going to go over how to simplify exponential expressions. And I just want to show you a couple of examples. Now, let's take a look at this first one over here to the left-hand side. Remember, the rule says that when the base is the same, you can simplify by subtracting the exponents, right? The problem here is that this base 8 and this base 2 are not the same, right? So the question is, can we make them the same? Can we make, let me write that down here. Can we make the bases the same? And if you can, then you can go ahead and apply the rules for exponents, right? So let's just take a quick look at this one. Now, we know that 8, remember one of my favorite sayings is that difficult problems are really just a bunch of simple problems that they have stacked on top of one another. Okay, so we need to practice looking for the simple problem in here. And the simplest problem that I see is the 8. I'm actually going to change 8 to 2 cubed, right? Because 2 times 2 times 2 is 8. Now let me just go ahead then and just put that in parentheses, and let me write everything else around it exactly the way it looks like up here. Okay, so what I've done is I simplified 8 to 2 cubed, and I chose 2, right? Because the base down here was 2 and I'm trying to match it up. Now I can just go ahead and apply this rule here, where when you're raising an exponent to another exponent, you multiply. So now look what I've got. I've got 2 to the 9th divided by 2 cubed. And now my bases are the same, which means I can subtract the exponents. And my final answer here will be 9 minus 3, or 2 to the 6th. And that would be the final answer for this particular simplification. Now, again, we're not solving the problem, we're just simplifying this particular expression, okay? So there was one example of how to do that. Just take a look at the two numbers, the two bases, and see if you can make them the same base by doing some kind of a number tree, for example, or any of that sort of thing. Now let's look at this particular problem over here. And what do we have? Well, again, we have kind of the same problem, except that this is really 2 times 6, right? So that's one way I could go. Or I could just go ahead and do the prime factors for each of the individual expressions, all right? So what do I mean by prime factors? Basically what you do is the number tree for each one of these. So let's just take a look at 6. I know that 6 is 2 times 3, and both those numbers are prime, and that's what prime factoring means, okay? So now I'm going to say 2 times 3, again, replace that 6 with just 2 times 3, and then square it. Let's see if we can do the same thing with 12. I know that 12 is just, 3 times 4, and then 2 times 2. So it really is just 2 squared times 3. So let's just put that down here. 2 squared times 3. Okay? Now, simple problems, difficult problems are just simple problems stacked up. And as you can see, it's starting to happen here. When I have 2 times 3 both raised squared to the second power, it's really like saying 2 squared times 3 squared. Again, put it on top of here, and that's 2 squared times 3. And I'm just going to put to the first here because that's what, when it doesn't have anything, that's what it is. It's that number 1. When I see this, all right, I continue to do simple problems. 2 squared over 2 squared factors out to 1. These bases, the 3's, are the same, so I subtract the exponents, which gives me 3. And there's my answer. Now, I could probably have done this a slightly different way, right? I know that 6 squared is 36, and this is just me checking, divided by 12, and 36 divided by 12 is indeed 3. Okay, so again, the trick that I wanted to show you in this example was take a look at the base, see if you can actually prime factor and make the bases the same as what's in the denominator, for example, and then just go ahead and simplify and apply the rules of exponents. Okay, I hope that was helpful.